Alright, it's time to begin our year on functions. And what a function is, it's just any relationship that essentially maps every x value to every y, or to one y value. And what I mean by that is everything in our domain must be mapped to something, a y value, and that y value is what we call our range of a function. So how do we test to see if something is a function? Well, if we have a map like this, essentially this is our map. This is, if it's a function, this would be some function f. Well, what this is saying is that when 2 gets mapped, goes to 1. An x value of 3, if you put it in like a function machine, becomes a 3. 5 goes to 2, 4 goes to 4. The question is, first, does every x value go somewhere? Yes, they all are being sent somewhere. The second question is, are they each being sent to one and only one y value? And the answer there as well is yes. So this is a function because it passes those two tests. Now here's two other ones I can look at and ask the same question. Are these functions or are they not functions? Well, the first one is going to be no, it is not a function because this element b here in my domain is being sent to two different places. I can't put my card into a machine and get 2 one time and put it in again and get 4 the next time. That can't possibly happen. So no, it is not a function. This one here, yes, it is a function because everything's being sent to some place, even though they're all ending up with 2. We're all getting $2 back, essentially, if we all put in our cards. We're still going and getting something each time. And it's the same something each time, not being sent to 2 different places. So everything is good. Now, if I would have another element D in here that didn't get sent anywhere, that would make this a no, not a function anymore. Because you can't put your card in and have nothing happen. It must be sent somewhere. Alright, now another way we can look at these is if we had these, the set notation. So we're going from A to B as a function. A being mapped to B is what this means. So again, the question is, do we have functions here? We look at it the same way. All 3 elements of my domain are being sent somewhere. They're not being sent to multiple places. So yes, this is a function. In this one, they're all being sent somewhere. However, A is being sent to 2 different places. So because of that, no, this is not a function. We can't be sending it to 2 different places. And in number 3 here, this also is going to be no, because even though things are being sent only one place, C is not being sent anywhere at all. So we do not have a function. And finally, the last thing we would look at is graphically. And the way we do it is with what's called the vertical line test. So what that means is if I draw a vertical line anywhere here on this graph, if it is a function, it would touch that function once and only once. So what that means here is, like for this first one, as I'm going across, if I'm drawing a vertical line, I'm only touching it once no matter where I go. That makes this, yes, it is good. It is a we say it passes the vertical line test because it only hits at most one time. So yes, it is a function. Same with this one. No matter where I draw my vertical line, it's going to touch just once. So also y equals x squared plus 2 is also, yes, a function. Now this one right here, if I draw vertical lines, well, even if I just draw one right there, notice how I have 2 spots right there where it touches. So it does not pass the vertical line test. No, that circle is not a function. So lines are functions, quadratics or parabolas are functions, but this circle is not. And here's just a couple more examples of ways you can see what is and what isn't a function just based on the picture. And that's what we're going to do a lot of is getting the pictures of all these graphs.